we need to do just a little bit of preliminary work so that we can be ready to deal with different types of angles and the conversions that are associated. There's three primary things that we want to take care of. First of all, everything today is about conversion of angles. One thing that we're going to do is convert angles between decimal degree and degree minute second notation. Okay, that's one thing that we want to accomplish. DMS represents degree minute second. We also want to be able to convert angle measures between revolutions, degrees, and radians. That's the second thing. That's a very common conversion that we'll be doing. We'll develop why that conversion factor exists and how it works. And the third thing is really a preparation for some trigonometry work that we're going to be doing in a couple of weeks, and that is that we want to be able to convert integer degree measurements into fractional radian measurements in terms of pi. Those are the three primary things we want to do. Now, first of all, we're going to start out with the degree minutes and seconds work. One revolution is 360 degrees. Everybody knows that. So basically what we know is that we have a conversion factor. One revolution is 360 degrees. We treat that as a conversion factor. We also know that we can take the degree and break it up into 60 parts called minutes. And we have 60 minutes. The symbol for minutes is a single tick mark, similar to the symbol used for feet. To give you a little bit of perspective about this, if you had the surface of the Earth, the circumference of the Earth, let's say we were at the equator, okay? Somewhere in the middle of the Earth, buried in some hot molten magma, is the center of the Earth. If you could make an arc that was 1 degree out at the equator, of course, you'd have to go 360 degrees to get around the circumference of the Earth, right at the equator. How far do you suppose you'd have to travel in order to navigate 1 degree of, let's see, I guess this would be 1 degree change in longitude? Exactly. It depends on the size of the Earth. The Earth is about 25,000 miles in circumference, roughly. That equates to about 70 miles. So if you drive 70 miles right at the equator, you will have changed by about 1 degree. This is just to give you some perspective on how these compare. 70 miles, roughly. That's 25,000 miles circumference divided by 360 degrees. What is it? 25,000 miles around the Earth. Yeah, 69 miles, roughly 70 miles. A minute, of course, is a 60th of a degree. So if you took this distance and broke it into 60 parts, you're going to travel a little over a mile. So you can walk 1 minute of 1 angular minute along the surface of the Earth without too much trouble. Now you can break that down even more into seconds, and the symbol for seconds is similar to the symbol for inches. So just as we break an hour into 60 minutes and 60 minutes into 60 seconds, we do the same thing for angular measure. And a second, an angular second at the equator equates to around 100 feet, which is not very far. So if anybody here ever used a handheld GPS system where it says your latitude and longitude, and you can keep track of it while you're walking, it'll trip about 1 second of latitude or longitude for every 100 feet or so that you walk. Second is so small that it's not used very often and for very many things, but minutes are very common. Well, what we're going to do is we're going to convert between decimal degrees and degrees, minutes, seconds. But here's the basic principle. There's no math involved here. This just sets you up for the logic that's used. If you have 2 degrees, 30 minutes, that's the same as 2.5 degrees, right? Okay? So what do you do, apparently, to convert minutes into a decimal? Well, if you have 2 degrees, 30 minutes, right, 2 degrees, 30 minutes is really saying that you have 2 and 30/60ths of a degree, which you treat it as a fraction, which means you're ultimately dividing by 60, and you have 2.5 degrees. Well, follow the same basic principle. If you have 28.25 degrees, what fraction of a degree have you got? You've got a fourth of a degree, or in other words, 15 minutes, just like a fourth of an hour. Now, those are kind of set up cases to help you just to think that a half of a degree is 30 minutes, a quarter of a degree is 15 minutes, and so on. Now we're going to look at some decimals that are not so easy to just switch over, but we're going to apply these principles. Under example 2, 28.25 degrees, what general rule are we following there? If we start out in a decimal and we want to convert it into minutes, what do? You reverse that. We'd take 28.25 degrees, and we take that decimal part, and we multiply it by 60. So we end up with 28 whole degrees. 0.25 times 60 is 15 minutes. Okay? That's the principle that we're going to employ to do these conversions. Okay? Well, let's do a couple that are not quite so clear-cut. Let's convert 127.679 degrees to degrees, minutes, and seconds. First of all, the sig-dig issue. We pretty much throw, because of all the multiplying and dividing here, here's a general rule of thumb that is used almost everywhere that I know of for converting and keeping track of sig-digs. 3 decimal points, rounding a degree to the nearest thousandth, that's 3 decimal places, has about the same precision as to the nearest second, or tenth of a second, somewhere in there. So when we express degrees, we'll always use 3 decimal places. And when we go to degrees, minutes, and seconds, we'll round the seconds to the tenth. And that'll keep us at about the same precision. So 127.679. First of all, we take the 0.679 and do what? Multiply it by 60 so that this becomes 127 degrees. 0.679 times 60 is 40.74 minutes. Okay? That's fine, but we want to go not into just degrees and minutes, which we've now done. We want to go into degrees, minutes, and seconds. So how do we convert this decimal part of a minute into seconds? Exact same thing. Okay? 0.74 minutes means we've got about 3/4 of another minute, which equates to somewhere around 45 seconds. So we can say that this is 127 degrees, 40 minutes, and 0.74 times 60 is 44.4 seconds. We've gone from a decimal degree measurement to degree, minutes, and seconds. Make that decimal stand out a little bit more. Look all right? Okay? All right. Well, we're going to come back in just a minute. We'll do that again, and we're going to do it on your calculator because your calculator is able to perform this conversion. We'll come back to it in just a minute, but let's do one in the other direction first. Let's convert 52 degrees, 17 minutes, 35 seconds into a decimal. Okay, well, the first thing we'll do is we'll get rid of the seconds. So how do you take these 35 seconds and roll them into a decimal part of a minute? Right, this is the same as saying 52 degrees and 17 and 35 sixtieths of a minute, which is the same as 52 degrees, 17.58 minutes. Okay, so we've lost the seconds. Now we're going to roll that one more time into pure decimal. And so this becomes 52 and 17.58 sixtieths of a degree, which if we divide that out becomes 52.293 degrees. Again, start out with seconds. Keep 3 decimal places on degree measurement. We don't count sig digs because it wouldn't matter if it was one whole number or three whole numbers. We'll always just keep 3 decimal places on those. To combine angles, what we do is we add degrees, minutes, and separately. And then if there's any seconds or minutes that exceed 60, we have to carry. So for example, if we want to take 23, 15, 55, and to that we want to add 61, 48, 9, and also it's worth noting that on minutes and seconds, if you have a single digit, 1 through 9, usually put a 0 in front of it. And it's a good habit to get into because a lot of calculators do require when you enter it to have both placeholders. So we put a 0 in there. That's usually the way it's written also. Add them up and we've got 64 seconds. 15 and 48 is 63 minutes. 23 and 61 is 84 degrees. Well, that's the total, but it certainly isn't right because the first problem here is 64 seconds. So we can make how many minutes out of this? We can take another minute over here, and that leaves us with 4 seconds. This becomes 60. That becomes 64, but 64 minutes isn't acceptable either, so we have to call it 4 minutes and take those other 60 minutes and roll them into another degree. So we've got 85 degrees, 4 minutes, 4 seconds. Thank you. 85 degrees, 4 minutes, 4 seconds. And we've got them added. Subtraction is handled similarly, except we may need to borrow minutes or seconds. All right. Well, start out just as you would normally with longhand subtraction. You start on the right. 20 seconds minus 40 seconds. We can't do it. We need to borrow a minute. So we're going to lose 1 minute, call it 6 minutes. But that gets us up to how many seconds here? 80, right. That bumps us up to 80 seconds. So 80 minus 40 is 40 seconds. 6 minus 12, same boat. So we need to borrow a degree. Becomes 37 degrees, but we now have 66 minutes. 66 minus 12 is 54 minutes. Now we're okay. 37 minus 15 is 22 degrees. 22 degrees, 54 minutes, 40 seconds. We've got them subtracted. The second thing that we want to accomplish today is convert between revolutions, radians, and degrees. I'm just going to have you watch something here. There's a little blip that I've got on the internet that explains what a radian is particularly well. Radian measure is based on properties of the circle. For example, first of all, this is what a radian is. If you take a radius, which is, of course, the distance from the center to the outer edge of the circle, and we use that radius and another radius to form an angle such that we take that radius and we're going to wrap it around the outside of the circle. So we take that radial length and we wrap it right along one edge. And then we close off that arc and form a central angle. What you see right there is 1 radian. Now that seems kind of convoluted, but that's going to be particularly useful for several reasons. A radian, that's 1 radian that you see pictured, that's somewhere in the neighborhood of 57 degrees. We're not going to use that as a conversion, but that's kind of a rough idea to help you picture how big a radian is. It's about 57 degrees. Now, how many radians approximately do you think it would take to wrap around that entire circle? We know it takes 360 degrees. How many radians, roughly? A little bit more than 6. Okay, well, if we have an angle measure of 2 radians, that means it's the angle formed when we take 2 radial lengths and wrap them around the outside of the circle. So an angle of 2 radians is quite a bit more than 90 degrees. It's about, roughly, a third of a circle. Moving right along, here's the fact that we want to pull out of that. The circumference of a circle is given by 2 pi times r, right? That's from our geometry unit. The circumference of a circle is 2 pi r. Then we know that we have 2 conversion factors down there. One, we already established that 1 revolution is 360 degrees. And 360 degrees, the distance around a complete circle, is 2 pi radians. A radian is an angle, but a radius is a length. But if we take a radius and start wrapping it around, it's going to take, since it takes 2 pi times the radius to find the circumference, it takes 2 pi radians to get around the outside edge. So in fact, you can now tell me exactly how many of those radial lengths will it take to wrap all the way around the circle. There's a little bit left over here. We've got 1, 2, 3, 4, 5, 6 of them. 6.28. Why 6.28? That is 2 pi. It takes 2 pi radius to find the circumference, which means it takes 2 pi radians to wrap around the outside of a circle. So there's the conversion factor that we want. 1 revolution is 360 degrees, or in other words, 2 pi radians. And the bottom one is particularly useful. Half that circle, 180 degrees, is just a little bit more than 3. Or in other words, that is pi. So 180 degrees is pi radians. It's a conversion factor that we'll be using a lot. Okay, let's do some conversions. 138.6 degrees into radians. Let's convert. We want to get rid of degrees and go into radians. Your conversion factor, 180 degrees, is pi radians. The units of degrees will cancel, and we just perform the conversion like we have before. 138.6 times pi divided by 180. Well, if you multiply that out, here we have 4 sig digs. We convert this over, we end up with 2.419 radians. radians. Now try and get a sense for radians while you're doing these problems. 138.6 degrees, is that more or less than a half of a revolution? It's a little bit less than half. So 2.419 radians is a little bit less than half, because we know that a half a revolution is 3.14. Okay. Well, let's do another one. Let's convert 2.68541 radians into degrees, minutes, and seconds. First, we have to go to decimal degrees. .68541 radians to degrees, minutes, and seconds. Well, first of all, we just do this conversion and get it into decimal degrees. We're going to keep a whole bunch of sig digs here. 2.68541, if we perform that conversion, you should get 153.839 degrees. Let's stop for a minute. Everybody agree with that? Oh, crying out loud. Yeah, that was wrong. That should have been 0.863, right? Doggone it. 153.863. I apologize for that. Everybody got that change? 863. Okay, so then this becomes 863, and we take the 0.863 times 60. And we get 51. .78. How's that? Does that agree with what you did when you do it on your calculator? Everybody okay with that? I don't want to leave you hanging if I've confused you. Okay. Well, here's another one. Same principle. Let's convert 3.75 revolutions to radians. Now your conversion factor here is 1 revolution is what? 360 degrees. Or, we're not going to degrees though, we can go straight into, don't use 6.28, that's rounded. Use the exact value of 2 pi. A complete circle has 1 revolution, 2 pi radians. We could use 360 degrees if we were going to degrees, but we're not. We're going into radians. And there's no need to use degrees as a middle step. Revolutions cancels off, and we're left with radians with 3 sigdigs. 23.6. And those are radians. 23.6 radians when we're done. Well, typically, if you're dealing with small angles, you would use degrees or radians. Anytime you exceed a complete revolution, then revolutions is the most common unit. Where it's used, degrees are used everywhere. Radians are used, you'll see frequently, or you'll see later on when we start doing waveforms. For example, the sine wave. The sine wave is more easily represented in terms of radians than it is in degrees. What's that? Oh, man. The cosine wave. The cosine wave can be more easily viewed using radians than it is in degrees.